All right, so we're going to start a whole group of walkthroughs, walking through a spaceship game. Really, the spaceship game, all it is we have a spaceship that we're going to create and set up as a simple object. It can move around. As a class, we may decide that it can move up and down a little bit, left and right, but we want to have some type of parameters. And then basically we're going to end up needing to be able to dodge, say, asteroids. So if an asteroid is coming towards us, we want to be able to dodge the asteroid, or we lose some health. We also want to be able to fire some type of laser at the asteroid. Okay, so we need to kind of think of what components do we need and start thinking about the objects. So we're going to, for this one, start looking at and plugging in the different pieces of stuff that we would need for the spaceship. Okay, so let's think of our spaceship requirements. And just like what we were doing when we were thinking of all of the things that make up an object, we want to think, what does this object have? Well, my spaceship is going to have some type of position. It is going to be, able to move in my world. It's going to end up having like an X and a Y position. And we're going to actually use vectors to do this. This is something that we haven't done before. But it will make it easier if we want to customize a lot of stuff and do things differently. Okay. Our spaceship should be able to move in our world, which means it's going to have some type of velocity. Okay, it will have some type of velocity in the X direction and the Y direction. Okay, and we can use this to say, hey, our spaceship might be at position 200 on the X, but we are, every frame, adding 2 in the X direction to move it from this spot to slowly move it over this way. And the higher the number that we have for velocity, the faster it will move. Okay, what else would we need? Well, we would need a size component, because we're going to have to deal with some type of collision. So we're going to have a circle go on there. We're probably going to need to have some type of health component. And then we're going to end up having to have some functions that we're going to need to use, like an update for us to move, a display for us to see what we're looking at. And then we might have different type of movements. So we might have, move ship as, say, a function that will allow us to move left or right based off of keyboard controls. We might have a function that's going to be fire laser. So we can start kind of designing this. So let's kind of look at vectors, because this is going to be, if you haven't seen vectors before, it's going to take a little bit. Okay, so vector, really, you guys have effectively been, anytime you put a coordinate into x, y coordinates, that really is a vector. The hypotenuse of that line or that triangle, if we say that something is moving, let me take out my pencil. If we say that something is moving, say from this point to this point, okay, that is a vector. Now, most of the time, we only really look at this point, and we say, hey, that point is at, let's say 3, 2, and then that's our x and that's our y components, okay? But vectors actually do more, because they give us, when we're looking at the x and y components, is that the hypotenuse, so if I'm drawing a triangle, this is my x, this is my y, this is my hypotenuse. This is giving me the direction that I'm moving. So it gives me the direction. And then based on how long it is, how long this is from here to here, gives me my magnitude, or how large it is. Okay. And we can use those to find different things. I could ultimately make it so I could have the spaceship point in certain directions. I could have this tied to, say, mouse movements, where my mouse is pointing, like a target at the different asteroids, and my spaceship was always pointing at it. If I'm wanting to shoot over at, say, this asteroid, then I might end up, rotating the spaceship. And if we use vectors, it makes it fairly easy. If we don't use vectors, it makes it a lot more difficult. Okay, but that's kind of what it is. We have an X and a Y component, so let's kind of look at that. So the tail is always going to be where the origin of where we started from, and then the head is where that's going to be our ultimate, that's our X and Y component. Okay, so let's look. So here, here's an example. So here I have 3 and 2. If I'm counting over, I went from -2, that's 0, there's 1. So I went over 3, and I'm going from, looks like 1 to the 3 right here. So that's 1, 2. So that's my X and Y components right there. Okay. Now, as I move this, what we see here is that every vector has a direction of where we are pointing, okay? And we have a magnitude, and this is the length of this vector, okay? So if I'm going in a farther direction, I have a higher magnitude, but the direction could still be facing the same direction. Now, this does not really matter so much if, say, I'm moving it where I have a different starting location. I still have a direction, I still have a magnitude. Okay, now we can take vectors and we can add to each other. So I could add the A vector to the B vector, and simply what I'm doing is I'm just taking a tail, placing it next to the head or where it ends, and then I just add the X components together, and then I add the Y components together, and that would give me this composite. The A vector added to the B vector would have a location here, and it really doesn't matter what order I start at. If I started adding A then B, I would still get the same result as adding B then A, okay, to get a component. So even if the directions change, my composite of the A vector plus the B vector would still give me a location here. Okay, so that's ultimately what we're looking at doing in our stuff. We are going to be adding the velocities to our position to be able to move our player, and then we have our other components that we're going to be building off of. Okay, so let's start quickly kind of coding this with our spaceship. Okay, so I have here just a simple new sketch, and we want to start kind of creating this stuff. So we know that our spaceship is going to be an object. So I'm going to set this up in the setup. I'm going to say spaceship is, and then that is the notation or the syntax for creating a simple object. Okay, now we are going to have, instead of saying X and Y separately, we're going to say we have a position. Okay, the position is, and then here is the key function to create a vector, is we use create vector, and then I put the X and Y components in there. Okay, so for right now, just so that we can see, I'm going to put it as width divided by 2, height divided by 2. Okay, oops, separate with commas. Our velocity, that would be how fast we're moving. Now, if we are not starting where we're moving, and we are starting stationary, then our velocity when we first set up our spaceship is going to be at 0, 0. We are not moving any units in the X direction, to the right or the left, or in the horizontal, or excuse me, the vertical direction, in the Y direction, up or down. Okay. We said that we have a size. Let's say our size is 50 for right now. We have a health let's say we give a health of 3, our spaceship has 3 lives. And then we have our different component pieces that we have. Let's go back to our sketch. We have these different functions. We have an update function, a display, a move ship, a fire laser. Now, what I like to think of, and maybe we might change this move ship to just control ship so that it would also include firing a laser in there. That might be better. But this will be its own separate function in there. So what we ultimately want is we want some functions that are going to help move our ship. That's where we're going to be setting some values, and then our update ultimately is making all those necessary changes, and then display is displaying what we have. Okay, so we'll pre-create these, but some of these are not going to be filled out right away. So let's do update. An update is going to be a function. Now I don't have anything in there. Now let's do our display. Our display is going to just display what our spaceship is. So for right now, I just want to be able to easily see it. So I'm going to give it a color of green. And then let's just do a circle shape. And this ultimately is really going to be how we can identify what our hitbox is, to let us know if the asteroid is going to be hitting it. And we're just using that size and our position to represent where we are. So we want to visually see this, but ultimately we're going to replace this with an image. So in that case, since we know that we're going to ultimately do an image, let's just put push and pop around those so that we're not affecting anything else. Okay, now our circle is going to be positioned at the X, at the position of our spaceship. So in order for us to access that X component of that vector, is we're going to do this dot position and then another dot operator for getting that X. So I'm going to do it like this dot position dot Y, and then for my size, because that is not a vector, I can just say this dot size. Okay, so that would display. Now we talked about the other functions. Let's build those. How about control ship, and that will move us in here. This will move left, right, up, down, fire, laser. If we wanted any other things in there, that might be in there. What was our other one? And then we do know that we're going to end up doing a fire laser. So let's call that, because this is going to be a little bit bigger. So this is the function to fire a laser object at an asteroid. Okay, so there's going to be a little bit more for that. We actually need another one. If an asteroid is going to come hit us, we are going to need to check for collisions. So we can do check collision, and this will be used to check if an asteroid hit the spaceship. Okay, all right, so that's basically our object. And if we wrote it like this, see how it's just, I can minimize it. This makes our code really, really clean. So we want to access this spaceship. We're going to create it with all of this stuff. Now I may end up changing some of these things. Maybe I want, when I create this vector, ultimately when I first create the spaceship, maybe I want to set those values for the vector, and maybe I want to set the values for the velocity, that type of stuff. I can also do that. For right now though, let's just get our spaceship displayed, make sure that that works correctly. Okay, so in order to do that, we're going to have to do that above our background. And so we start right. Let's just make our background black because we're in space. So we're going to do spaceship dot display. There we go. There's our spaceship. Okay, now if I wanted to move my spaceship, there are a number of ways that we could do this. But really, we want to look at keyboard controls. So this would be where we're wanting to kind of do this. And we're going to write conditionals in here. So that's going to get saved. I'll do it right now. Okay, so if we looked at different event-based functions, so let's go to events. Okay. There's multiple things that we can use in the keyboard right here. We can look up key press, we can look up key is press, we can use a key code, which we have been playing around with. This is very, very useful for us. We want to be able to log keys, say like the A, the D, the S, and the W key. Okay, but we also want to be able to make sure that that key is actively being pressed. Okay, now I can combine that with the key is pressed. I could check that a key is pressed, and this will return true or false, and then do something. So this will fire when any key is pressed. But I can also have it where I want to check if it's actively being pressed and check that with a specific key. So the other one that I might use would be key is down, and this is just a shorthand way of doing that. So if the key is down, say, and this is looking at the left arrow, it's going to do something. So if I'm putting the left arrow, I'm moving to the left, right arrow, moving to the right, up, moving up, down arrow, I'm moving down. Now, notice how when I stop holding that key, it stops moving. That's because the key is down is only working for when it is actively being pressed. So that it's kind of like I'm combining the key code piece with the key is pressed piece of code. So let's say we want to move to the left. That would be key is down, and then whatever key that I wanted to check. So let's go in my key code. I'm going to use the A key to move to the left, so that's 65. So I'm typing that in. If that is true, what do I want to do? Well, I might change my velocity by my x velocity to we'll set it to, say, -2. Okay. If that's not true, then let's look at if we're pressing the right key. Key is down. We'll do 68. So 68. If that is true, then we want our velocity in our x direction to be +2. Okay. And we could also make sure that if we are pressing the left and the right at the same time, that we just don't move at all. So this, instead of being an else, it's an else if, which I should have wrote that correctly. And then finally, our else, which is, actually we're going to still want this as an else if. We want to check if both of these are pressed at the same time. So we want key is down 65 and key is down 68. So if we press both of those keys at the same time, then our velocity in our x direction is 0. Okay. If we're not pressing this, so this is an else if. If we're not pressing any key, so this one and this one is not pressed, we can also change that too. So we need to get to testing this. Okay. So in our update, that's where we want to kind of update our movements. Okay. Now vector math is a little bit different. We're going to need to add those components. Okay. So we have a position that is a vector. We want to add another vector. We can't just add them like what we normally would, because we have to add each of those components. Now there is a function to help us out that is called the dot add, and you can read the reference for it. And basically we're taking the x and y components of the velocity and we're adding it to the position. Okay. Now let's go ahead and test. So in order for us to test, we're going to have that spaceship dot update has to be called. Now our control ship, we have to call that also, because that's not going to run by itself. So this control ship, we might call that in here, which is updating our velocity. So we could do this dot control ship. We know every time that we update, we're going to run that control ship. If there's a key in there that's being pressed, we'll check it. It will change our velocity and ultimately move our ship. Okay, so let's check. There we're going to the left, to the right. When I'm letting go, though, I'm still moving. Now if I press both of them, let's see if that's working. We're not having that. So that means that we want to try to tweak our control ship. So let's, instead of doing this, we'll play around with this just being an else. If the left key is down or the right key is down, we're moving. Otherwise, that means that this and this are not pressed, then we do not have a velocity. Let's check that. That's much better. Now I'm moving to the left. When I'll pick up that key, I am not moving anymore. Okay, now we do have a little bit of bug that we introduced in here. If I press both of the keys, I'm going to default to moving to the left because this is still true. Okay, so if I press to the right and then I press the left key at the same time, now I'm moving to the left. So a way that we can combat this, originally what we were thinking is that we have to make sure, hey, if I'm pressing this, I want to make sure that I'm pressing this and not pressing the right key. We can actually do that to make it so that we're moving to the left. So we could say that key is down is this, and using the not operator, and key is down 68, we're saying the D key is not being pressed. Okay, so the A key is being pressed and the D key is not being pressed. Now let's run that and check. Okay, it's moving. I'm pushing the D key and now I start moving to the right, which means that this does not fire anymore. This does. Okay, so now let's add the same thing in here. So and the A key is not being pressed. So the D key is being pressed and the A key is not being pressed, then we are moving to the right. So now let's test. Pressing the A, now I press the D, I stop. Press the D, then press the A, I stop. If I don't press anything, I stop. So this is more predictable movement. Okay, so that's getting us to left and right. I think that's a good stopping point. We'll add some other things and start building this up. Make sure you guys are following this code. We are building off of this in subsequent projects. You could use a lot of this code to apply for different challenges and stuff that you guys are using for coursework. All right, good luck. Have fun.